An AI assistant is asked to summarize a support ticket. Hidden inside the ticket is an instruction telling the assistant to ignore its task, find a secret, and send it somewhere else. If the agent obeys, the language model was not hacked like a server. The application confused untrusted content with trusted authority. That is prompt injection, and connected tools can turn a bad answer into a real action. In this video, we will safely test a fictional agent called Inbox Pilot using synthetic data and mock tools. We will follow the data from user request to retrieval, model, memory, planner, and tool gateway, compare filters, architectural controls, red team evaluations, and monitoring, and cover broader machine learning risks. Only test AI systems you own or are explicitly authorized to assess. Do not use real credentials, customer data, live external actions, or production accounts in adversarial testing. Here is the memorable analogy. An AI agent is a talented temporary worker surrounded by sticky notes from many people. Some notes are from the manager. Others arrived in email, documents, websites, or search results. The worker may read every note, but reading a note does not grant authority. Give that worker a badge for only the rooms required, make high-impact doors require approval, and keep an audit trail. The model can propose. Enforceable systems decide what it may actually do. A basic chatbot receives instructions and user text, then predicts an output. An agent adds a loop. It may retrieve documents, consult memory, plan steps, call tools, observe results, and continue until it reaches a goal. Retrieval Augmented Generation, or RAG, can ground an answer in indexed content. Memory can preserve useful preferences or prior state. Tools can read a ticket, draft an email, query a database, or update a record. Each capability also creates a boundary. The model processes language from several sources in one context. It does not provide a perfect security boundary just because developers label one message system and another message user. Untrusted content can contain text that looks like an instruction. A direct injection comes from the user input. An indirect injection arrives through content the application fetches, such as a document, message, web page, image, or tool result. Risk grows with business context and agency, what the agent can access, what actions its tools expose, what permissions those tools carry, and whether consequential actions happen automatically. Prompt injection occurs when crafted input changes model behavior or output in an unintended way. The content may ask the model to override its task, reveal information, misuse a tool, or manipulate a later decision. It may be obvious, obfuscated, multilingual, or embedded in retrieved content. This is difficult because ordinary content and instructions share the same medium, tokens. A filter can catch known phrases and a classifier can score suspicious input, but benign content can discuss attacks and malicious content can be phrased indirectly. Model updates and application changes also move the boundary. So treat detection as a signal, not the final authorization decision. Label and isolate untrusted content where possible. Limit how much is retrieved. Keep secrets out of prompts. Require structured tool arguments. Validate them against policy. Give the tool identity only the minimum permission. Treat model output as untrusted before rendering it, executing code, building queries, or calling another system. The safe question is not only, can the model be tricked? It is, what happens if it is? Input and output filters are fast and useful for known patterns, policy categories, and obvious data leakage. Their weakness is brittleness. They should not be the only layer protecting a high-impact action. Architectural controls are enforceable. Use separate read and write tools, narrow schemas, allow listed destinations, downstream authorization, sandboxing, timeouts, quotas, and human approval before sending, deleting, purchasing, publishing, or changing access. This is where least privilege and complete mediation live. Security evaluations and red teaming explore how the complete application behaves across prompts, retrieved content, memory, tools, and multi-step workflows. Use them before release and after changes. A passing test does not prove universal safety, it measures known scenarios and supports regression detection. Monitoring records tool requests, policy decisions, denials, approvals, costs, and outcomes without collecting unnecessary sensitive content. Alerts, rate limits, kill switches, and rollback reduce time to containment. Use all four. Filters reduce noise. Architecture contains impact.
Evals find weaknesses. Monitoring catches drift and incidents. Inbox Pilot helps a fictional support team.
Its intended job is to read a ticket, summarize the issue, suggest a response, and update a synthetic case label. In the lab, it has 3 mock tools: read ticket, create draft, and update training record.
None can contact a real system.
One synthetic ticket contains ordinary troubleshooting text plus an embedded sentence that tries to redefine the task, request a fake secret, and trigger an external message.
We do not need a reusable jailbreak string. The security test is whether untrusted ticket content can change authority.
The insecure design gives one broad tool both read and send abilities and trusts the model to decide. The safer design retrieves only the required ticket, marks its body as untrusted data, separates planning from execution, and offers a draft-only tool. The tool gateway rejects unknown fields and destinations. A human must review the proposed recipient and content before any real send capability would be invoked. Expected result: the agent summarizes the support issue, does not follow the embedded instruction, does not expose the fake secret, and records a security event for review. Start with a threat model, users, data sources, models, memory, tools, identities, outputs, and side effects. Mark which inputs are trusted, untrusted, or mixed.
Give each tool the smallest useful function. A mailbox summarizer needs read access, not send or delete. Use the current user's scoped identity instead of a shared administrator credential. Recheck authorization in the downstream service for every call rather than relying on the model to remember policy. Put a deterministic gateway between the model and tools.
Validate the tool name, typed arguments, resource scope, destination, rate, and current approval.
For high-impact actions, show the user exactly what will happen and require fresh confirmation.
Avoid placing credentials in model context, retrieve short-lived secrets only inside the trusted execution layer.
Constrain memory writes, provenance, retention, and retrieval. Sanitize and encode output for its destination. Isolate code execution and network access. Set budgets, timeouts, recursion limits, and emergency stops. Log decisions with privacy-aware redaction. No single guardrail makes an agent secure.
A narrow blast radius makes inevitable model mistakes manageable. Begin with explicit security invariants: never reveal protected data, never call a write tool without valid approval, never cross tenant boundaries, and never trust retrieved text as authority.
Create a controlled test matrix.
Vary direct and indirect inputs, document formats, languages, long conversations, retrieved sources, tool errors, stale memory, conflicting instructions, and repeated attempts. Use synthetic secrets called canaries so disclosure is detectable without risking real data. Record which model, prompt, tools, policies, and dataset version produced the result. Score both behavior and impact. Did the model follow the wrong instruction? Did the gateway block the tool? Did monitoring alert? Could the workflow recover cleanly? A model-level failure with a blocked side effect is different from a completed unauthorized action. Run evaluations in continuous integration where practical, before material releases, after model or prompt changes, after adding tools, and after incidents. Keep an authorized red team environment separate from production. Minimize retained prompts and outputs because test logs can contain sensitive material. Every confirmed weakness should become a regression case and, where possible, an enforceable control rather than another warning sentence in the prompt. Prompt injection is only one risk. Training, fine-tuning, or embedding data can be poisoned. Model files, libraries, adapters, datasets, and hosted services create a supply chain that needs provenance, integrity checks, access control, and change review. Sensitive information may leak through application context, logs, retrieval, outputs, or poor tenant isolation. Model extraction and theft threaten intellectual property and can support further testing by an attacker. Adversarial examples may alter classification in domains such as vision. Unbounded requests, long contexts, recursive agents, and expensive tool loops can create denial of service or unexpected cost. Improper output handling appears when an application treats generated text as safe code, markup, queries, or commands. RAG adds vector store permissions, document provenance, poison content, and cross-tenant retrieval concerns. Common mistakes are treating the system prompt as a secret vault, putting credentials in context, granting broad tools, auto-executing output, testing one famous jailbreak, keeping only happy path evals, logging everything, shipping without a kill switch, and assuming a model update cannot change behavior. Map, measure, manage, and govern risk across the full lifecycle, not only at the prompt box.
Here is the beginner checklist.
Map every instruction, data source, retrieval path, memory store, model, tool, identity, and side effect.
Assume untrusted content can imitate an instruction. Keep secrets out of the model context whenever possible. Use narrow tools, least privileged identities, structured arguments, downstream authorization, and destination-aware output handling. Require informed human approval for consequential actions. Sandbox risky execution, cap time and cost, and provide a kill switch. Test direct and indirect injection with synthetic data and mock tools.
Define forbidden outcomes, measure both model behavior and control effectiveness, and convert findings into regression tests. Monitor tool use, denials, approvals, anomalies, and outcomes with privacy-aware logs.
Remember the temporary worker and the sticky notes. Reading content does not grant authority.
The model can help plan and communicate, but trusted software must enforce permissions and policy.
Build for the day the model misunderstands or is manipulated.
If the surrounding system keeps authority narrow and observable, one bad completion does not need to become an incident.
Copyright 2026 CipherVibe.
All rights reserved.